Hello students, welcome to my lecture. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today my topic is display devices and color model. As I discussed in my last class, each display devices has set of pixels. Those pixels are set on or off to display any object. There are different display devices. So first display device which we discussed, that mechanism to display the object is a cathode ray tube. So this is the structure of the cathode ray tube where there is an electron gun, focusing system and a deflection coil. And there is a screen and the screen is coated with phosphor. Now when the electron beam is generated from the electron gun, it passes through the deflection coil and after passing it, it hits the phosphor coated screen. And when it hits the phosphor coated screen, a dot will be, the screen will be illuminated. So in this way we can display a particular pixels or dot in a screen. Now if we want to draw a line on that screen, so drawing of line means we have to successively illuminate a set of pixels. Now by varying the value of the, so this deflection coil basically deflect, this will change the position of the electron beam. So this basically guide where the electron beam will hit. So in this way we can successively illuminate the corresponding x and y. Now here what happened, the electron, so consider we have to draw a line on the screen, and to draw the line we have to illuminate 10 pixels. So what we do, the electron beams will hit all the 10 pixels and they will illuminate the pixels. Now the problem is that once the pixels will, any pixel will be hit by the electron beams, that the phosphor will glow and we can see the illuminated pixels for a fraction of time, and the meanwhile the illumination will goes off. So to keep the illumination constantly, that means if we want that our pixel will glowing constantly, so what we have to do, we have to hit the pixels repeatedly. And as we know that our human brain can distinguish 10 object or 10 character distinguishedly within 1 second. That means what? If you can see, so your brain can clearly distinguish 10 character within 1 second. Within 1 second, if you observe 10 character, you can clearly distinguish them. But if the number of characters are more than 10, in that case, you cannot clearly distinguish all the character. So the following the same strategy, what the cathode ray tube does, it repeatedly hit a pixels and number of hits is more than 10 times. So a particular pixels will be hit more than 10 times in per second, so that when the users or viewers will see that pixel, it seems to him that the pixel is continuously glowing. So in this way, if there are 10 pixels in a straight line, in a line segment, then all the 10 pixels should be illuminated constantly, and the number of illumination should be more than 10 times in per second, so that towards the viewer it seems that the line segment is a continuous line. So in this way, the cathode ray tube display any object. Now next, the cathode ray, what is the display mechanism? That means, so this is the technique how the pixel can be illuminated. But how this all the set of pixels will be illuminated to display an object? So there are two technique of illumination. One is called the raster scan and the second one is the random scan. Now first we will discuss the raster scan method, which will illuminate the pixels to display the object. Now in raster scan method, the technique is like that. The entire display devices, as you can see, has a set of a row of pixels. Now, what the raster scan method does, it starts from the starting pixel of the first row. So you can see this is the first row. So it start to illuminate the starting pixel of the first row. So then it scan all the pixels one after another to check whether it needs to be illuminated or not. After scanning the entire row, it reaches at the end, and then the electron beams come back to the first position of the next row. So that means the next pixel, the first pixel of the next row will be checked, and as per the requirement, it will be illuminated, and then again the scanning will be done through all the pixels in this line, and it will reach at the end. After reaching at the end, again it will come back to the next line, first position at the next line. So this coming back from the end of the previous line to the first position of the next line, so this coming back is called the horizontal retrace. So in this way, all the pixels in the all row will be illuminated, or it will leave as it is, and the electron beam will finally reach at the end of the row. That means the last pixel of the last row will be illuminated, or it will be checked. After doing so, again the illumination will be start from the first row of the first pixel. So it will go back from the last row of the last pixel to the first row of the first pixel. So you can see this arrow. So this is called the vertical retrace. So using this horizontal retrace and vertical retrace, the required pixels will be illuminated, and the corresponding object we can display the corresponding object through the screen. And this illumination, this entire process will be repeated so fast that our human being cannot recognize that those pixels are repeatedly illuminated. So towards our human beings, it creates an illusion that all the pixels are going continuously, so we can see the continuous image. Otherwise, some flickering effect will appear. Now, the next one is a random scan. So in case of random scan, the technique is little bit different from the raster one. So in random scan technique, all the pixels are not scanned. What happened here, in case of random scan, each object is composed of a collection of lines. So what again I am repeating, in case of random scan, an object can be considered as a collection of line segment. And in each instant, one line segment will be illuminated. So here you can see, if I want to draw a triangle, so what will happen? So this electron beam will start from this particular position, as you can see from the first image, and then it will illuminate the entire line. After illuminating the entire line, that means the first line of the triangle, it will start from this position and again go upwards to display the second line segment. After displaying the second line segment, again it will start from that position, come downwards to display the third line segment. So in this way, the complete triangle will be displayed, and this entire illumination will be done repeatedly, so that, and the number of repetition, that means number of times it will be illuminated, is more than the human visualization power, and so that the flickering effect will not appear, and human can see that it is a continuous image. So this method is called the random scan method. Now, next one is, so all the things we have discussed here about the black and white display. So this CRT technique which I discussed is to display a black and white image. Now, if we want to display any colored image, then we have to go for the colored monitor. In the colored monitor, the same technology is followed, but here the screen has two different layers of the phosphor coating, the outermost layer and the innermost layer. So if the electron beam hit the outermost layer, the green color will be displayed. If the electron beam hits the inner layer, then the red color will be displayed. Now how we can decide the which whether outer layer will be displayed and the inner layer will be, I mean, red will be displayed. That depends on the velocity of the electron beam. So the display of the different colors is controlled by the velocity of the electron beam. So if the velocity is too high, then the electron beam penetrate the innermost layer and hit the outermost layer, and the outermost layer will be illuminated and we can see a green dots in the outer layer. Similarly, if the velocity of the electron beam is less, then it will hit the innermost layer, and in that case the red pixel, we can see the red pixel. Now if the velocity is between the slow and fast, that means if it can penetrate the innermost layer but it cannot reach up to the outermost layer, so in that case what happened? So it will penetrate the innermost layer but it will not able to hit or penetrate the outermost layer. So in that case the electron beam will lies between these two layers, and a different color will be produced. It may be orange or it may be yellow. So in this way we can display different types of color dots on our display device. Now there is another type of color monitor which is called the technique which is called the shadow mask. Now in the shadow mask technique there are three electron guns are there. One is a red, blue and green. Different electron guns produces different electron beam. So if the electron beam is produces from the blue gun and if it hits the screen, phosphor screen, so blue dots will be displayed. Similarly, true for green and red also. Apart from that, there is a mask, which selection mask, which is called the shadow mask. Now this shadow mask plays a very important role. This shadow mask guide that those three electron beams will hit which pixel position. And another important thing is that here each pixels has three phosphor dot. So one phosphor, if one for red, another for green and another for blue. Okay, so if the electron beam generated from the blue gun will hit that pixel, then the blue phosphor will be illuminated and blue color we can display. So here, so this shadow mask guide the electron beams and it helps them to display a particular color. So this is the shadow masking technique to display the colored image in the CRT monitor. Now the next thing is the color model. This is very important topic which is called the color model. Now what is that color model? Color model is an abstract model. So all the colors which we can see are in our surrounding, all colors are not exist uniquely. Basically some very few colors exist, and by combining all those colors in different proportion or in different intensity, we can produce a set of colors, a range of colors, which is called the color palette. So this color model define that what are the primary color and what is the strategy to for the combination so that the different color can be produced. So there are different color module. One is called the RGB model. Second one is the CMYK model, and the third one is CMYK model, and there is another color model which is called the HSV model. So we already aware about the RGB model. So as you are dealing with any image editing software, or while you are typing, while drawing any object in the words, you can see while you are coloring, so this color model, RGB color model is coming. So you are aware about this RGB color model. So the first color model which I want to discuss is the RGB color model. So it is the most widely used color model in the computer graphics. This RGB color model has three primary colors, which is red, green and blue. So this RGB, these three colors are called the primary color, and this color model is represented by a unit cube. In this unit cube, it is cube, so it is represented by three-dimensional coordinate system, and here three axes are represented by RGB. So as you can see, this axis is represent the red color, this axis represent the blue color, and this axis represent the green color. And unit, as why it is called the unit model? This unit model because the origin is 0 and this value of this particular corner point is 1. So the length of each side is unit. Now here the origin where all the value is 0, 0. So this origin represent the black color. Now if we move along the red axis, then along the red axis, all the colors, that means G and B components are 0. The value of the G component and B component are 0. So we will get only the R component. So if we move at the end point of this, that means at this particular corner, so we get the value of this point as 1, 0, 0. So here the points are represented in three coordinates, that is R, G, B. So first value is the R component, second value is the G component, and third value is the B component. So here R component is 1, G component is 0 and blue component is 0. So it will display the red color at this particular corner. So similarly, if I go along the blue axis, so at this corner we will get the blue color. And if we move along the G axis, we will get the green color at this corner point. Now, here if you go through the GB plane, in the GB plane, in this corner, the value of R component is 0. So there is only green component and blue component. So with the combination of the green component and blue component forms a cyan color. Similarly, in the RG plane, the value of B component is 0. So here the green and red combine together and it forms the yellow color. Similarly, at this RB plane, the red and blue components are combined together, and where the green value of the green component is 0 and it forms the magenta color. And if you go at the corner point of, that means this point, where the value of three component is 1. So R is 1, G is 1 and B is 1. That means all components is present with their 100% intensity, entire intensity. So if I combine, that indicate if I combine red, green and blue together with 100 pure red, pure green and pure blue together, we can get the white color. So here you can notice one important interesting features, that here each color exists uniquely, and when we are adding one color with another color, we can generate a new color. So here the new color is generated by adding one color with another color. So that's why this RGB color model is called the additive model. Now another important thing is features of RGB color model is that this RGB color model is mainly used to display the object color of the object for the monitor or display device. Now next, there is another color model which is called the CMY color model. This CMY color model is called the cyan, magenta and yellow color model. This CMY color model is basically used for the printing purpose. So why it is used for the printing purpose, I am coming later. Now this CMY color model is called the subtractive color model. Why it is called the subtractive color model? Because if you consider the previous case in the RGB model, all the colors are 0, 0. That means Origin is black. Origin is black means my background is black. But in case of CMY color model, the background is white. And if I combine all the color, that means cyan, magenta and yellow together, then we can generate the black color. So here my background is white, and if all the colors are present together, then we can form the black. So black is my color, which composite color. Now from this black color, if I subtract the magenta part and the yellow part, then we can generate the cyan part. Similarly, from the black color, if you subtract the cyan part and the yellow part, you can generate the magenta part. And subsequently, if you subtract the cyan and magenta from the black, you can generate the yellow part. So here you can see black is the composite color, and from this composite color we are subtracting different colors, and by eliminating the color from the black, we can generate a new color. That's why it is called the subtractive color model. Okay. So here you can see that in the subtractive color model CMY, and there are by different combination and different colors are there, so a list is present. And another important thing which I forget to mention for the RGB color model, this RGB color model is called the 24-bit color model. So here R component, to represent the value of the R component, we need 8-bit. To represent the color component of green, we need 8-bit, and to represent the blue component, we need another 8-bit. So 8-bit for red, 8-bit for green, and 8-bit for blue. So that's why RGB color model is called the 24-bit color model. Now next, there is another color model which is called the CMYK color model. Now how the CMYK color model is different from the CMY color model? As I discussed, that the RGB color model is used to display the or color the object for the display device. It is not used for the printing purpose, because this RGB, so those component which are the primary color which is used to display the object, that primary color is not possible to manufacture. In our printer, the red, green, blue, those type of color is not present. If you open your printer cartridge, you can see the color cartridges are not RGB. They are the cyan, magenta and yellow. Now this cyan, and you can see from the CMY color model, the cyan, magenta, yellow are combined to generate the black color. But black color can be generated only then when the cyan, magenta, yellow is purely cyan, pure. That means the intensity of the cyan is 100%, magenta is 100%, and yellow is 100%. That means all components present with their 100%. But in our printer, the colors cartridge, the cyan color, magenta and yellow color which comes with our printer cartridge, those colors cartridge are not that much pure. Some impurities are there. Impurities are there means the cyan is not the 100% cyan color. The intensity is not the 100%. So in that case, if you combine the cyan, magenta and yellow to generate the black color, you can see the black color will be not produced. In your screen, you can see black, because in your computer, the cyan is 100%, the intensity of the cyan is 100%, the intensity of the magenta is 100%, intensity of the yellow is 100% in your screen. But when you go for the printer, the cyan, magenta, yellow intensity is not 100%. So when they will be combined, the black color will be not generated. Instead of black, there will be some brownish color. So what is the solution for the printing purpose? The solution of the printing purpose is, along with this cyan, magenta and yellow cartridge, another cartridge with black color is present in our printer, which can generate the pure black. So that's why this CMYK color model is basically used for the printing purpose. So if you want to print anything, and if you want that whatever I am saying through my computer screen, that color will be exactly printed through the printer, in that case you have to design, you have to color the object color the object using the CMYK model. If you use the RGB color model and then if you print the picture using the printer, you can see a different color set. Fine. So CMYK color model is used to draw the picture and print the same picture with the same color. Fine. Now, so in this slide, you can see a comparative comparison between the RGB color model and CMYK color model. So in the RGB color model, so this is you can see all RGB color model and CMYK color model, both color models are represented by the unit cube. So here, as you see, this is a red, this is green, and this is blue point. This is magenta, cyan, white, and black. But in the CMYK color model, this axis represents the cyan, this axis represents the magenta, this is yellow, and when we combine all the colors together, it's black. So that means from black, if we subtract it, we get green. From the black, if we subtract red, we will get the red. If we subtract the red, we can get some another color. So different colors you can get by subtracting one color component from another. So RGB is your additive color model and CMY is your subtractive color model. And that's all for this today's lecture. And one thing I just again want to mention, that in the next class we will discuss the different scan conversion algorithm, and to discuss all the scan conversion algorithm, you must have a very clear concept about the pixel, about the color model. So if you don't have the clear concept about the pixel and how the pixels are illuminated, how the pixels are combined to generate the object, you can't write your code, you cannot draw your object, you cannot generate your own graphics. Okay, so this is all about the today's class. Thank you for watching my video.